Hello and welcome back to Purus Java tutorials. In this session, we are going to cover the two most important topic of collection framework, that is deque interface and one is map interface. So in the last session, we had covered about the queue interface and we learned about the queues. Now, what is the deque interface? Deque is also known as the double-ended queue. So this is the short form of double-ended queue. Double-ended queue, what it supports is, unlike the queue, only supports the insertion of elements from the rear type and the getting of the elements from the front side. And in deque, it supports insertion and deletion from both the ends. And it is very powerful interface because it also implements the stack and queue interface. So let me just talk about stack a little bit. So stack is something like the last in first out, which is also called as LIFO. But the queue is the first in first out. Whoever comes first, that will go out first. So this is called as FIFO. So let's jump into our IntelliJ IDEA, and here I have the deque example. And there are few implementation of deque interface, that is linked list and array deque. Let's first see what all methods it has. So deque has add last, offer, add first, offer first, poll, and so on. So let's cover one by one. As we know that deque interface supports insertion and deletion of elements from both the ends. It's like from the rear also and from the front also. So here I had given like this. Let's just see in the representation how it works. This add last, offer, and add last, add first, offer first. Here add means it will add at the last. So just at the beginning only one element will be there. So here let me add how. The next element will come as R, add last, right? Add and add last, both adds to the last. And offer and add last, again U and question mark, this both will add at the last. So U and question mark, U, then question mark here. So add first, this method will add friends in the beginning. So how will not be now the first element, it will be friends. So let's just write here friends, and this how will be now here, and then R, then U, then question mark, right? Now after offer first, this hello will be added at the first. So this friends will be the second element now. So let's just write here friends how are, here it will be R, U, then question mark, and in the beginning what we added, hello. So here the element will be hello. Now the deque contains these many elements. So here deque.poll, it will remove the first element. So what is the first element? It will be hello. This will get removed. So after the poll method, the new queue elements will be here like this. Friends, how are you? The hello will be pulled out. Now deque.remove, again this will also remove the first element, and there are some difference between pull and remove which is there in the queue also. You can refer the queue videos. So queue.remove will cause this friends to be removed from this queue. Now the queue will contain how are you, then question mark. Now let's come to the methods that will remove the elements from the last. Poll last and remove last. Here also there are some differences, like if the queue is empty, then this method will return null. In this case, it will throw the exception, no such element exception. So this too will remove the element from the last. So after poll first method, what will get pulled? The last element. So the question mark will be pulled out. So here the question mark will get the output. Now remove last. After question mark is pulled out, what is there? U is there. So U will get pulled out here. Now let's come to some examining method of the queues. So peak, get first, peak last. These are the methods which are used for examining the queues, whether elements are there or not. Peak returns the first element of the queue. Even this is the same as pick method, get first, and peak last will return the last element. Since the deques also implements the stack interfaces, so you can use the push and pop method to insert and remove elements from the deque. So push method will insert the element from the first. So push here, it will get added at the front, and the pop will remove the last element. So these two push and pops are the methods which is defined in the stack interface and you can use in the deque. Now how to get the size of the deque? You can use the size method, and you can ultimately pull all the elements or remove all the elements from the queue. So after doing all these things, your deque will get empty. You can see all the outputs by running this program. Now let's come to the map example, and we'll cover here the map data structure. So map is nothing but a key value pair data structure where we can store, let's say for example, we want to store some uh, roll number and name of the students, then we can keep roll number as the key and the name as the value. Let's go and see in IntelliJ one of the example. So here I have defined the map, and there are multiple implementation of map, that is Hashmap, tree map and linked Hashmap. These three are the implementation of map. One more is also there, that is concurrent Hashmap, which is used for multi-threaded environment. So let's come to Hashmap first. Hashmap is the implementation where it keeps the element, or it inserts the element based on the hashing algorithm. So what is hashing algorithm? It generates a memory location based on some hashing code, hash code of the object. Now I have put these three elements in the map: Harish, Xavier and Arun, and the roll number is 1, 5 and 2. So these 1, 5, 2 are the keys and these are the values. So based on the key, I can retrieve one of the values. Let's see how to retrieve the elements from the map. Now to retrieve the elements, you can iterate the map using the key set iterator or the entry set iterator. These are the two ways you can use. So let's talk about the key set iterator or your new for each loop using the key set. So key set will return the keys, and the keys are nothing but here the roll numbers, and based on the roll numbers, here the roll number I'm getting, and then based on the roll number you can get by using .get method on the map interface. So what is the value of this one? This will be like Harish, Xavier and Arun. Let's just run this program and see. Iterate by using key set here, Harish, Arun and Xavier. And one thing to notice here, that in the way in which the hash map has put the elements in that same order, I'm not able to retrieve here, because the hash map does not guarantee that the order in which it is inserted, in that same order we can retrieve. Let's say for example, if you want To retrieve in some order, let's say some natural order, you can use the tree map. Tree map, it sorts the keys based on natural ordering. So if you are using the tree map, you will get output like 1, 2, 5. 1 Harish, 2 Arun, and 5. Okay, let's talk about linked hash map. If you want the way in which the elements are put into the map, if you want to retrieve in the same way, you can go for the linked hash map. You can try out by just comment this one and uncomment this particular statement. The same way you can use the entry set. The entry set will retrieve one entry which is a wrapper kind of thing on key and value, and from this entry you can get the key and the value. So this is the iteration using the entry set. Now let's say if you want to fetch a single value from the map based on some key. So you can pass the key here and .get method you can use to get the value. So here what will be the value? 5. For 5, Xavier will be the output. Now there is one more method, contains key. So this method will determine whether this particular element is there as a key or not here. So is it there? No, it is not there. So it will return false. Contains value is one more method which is there in map interface, which checks whether this value is there as a value or not. So this will return true because Arun is already there. Now how to get the size of map? You can invoke .size method, and you can check whether the map is empty or not by invoking this is empty. Now let's say you are trying to put one more element which is having the same key, right? Here I have the key as 1, and again I'm putting here in this statement 47 number line value as Santosh. So what will happen? This value will get replaced by the new one. So it will override the value. So here I have just copy pasted the iteration code, and I will show you how this value is replaced. Here I can write as out after replacing Harish. Let's run this and see. After replacing Harish, what came? 1 as Santosh. Earlier it was Harish. Now let's come to the remove. So this remove method removes the element which has the key as 1. So it will remove this particular value, key value pair from the map. And this returns the value of the key. So this will print as Santosh removed. Now let's talk about one of the method remove. If you use while iterating the map in a normal map, you will get the concurrent modification exception. You cannot use like this. And to solve this problem, you can use the concurrent hash map instead of normal hash map. I hope this is clear. This code base is there in my GitHub area, which is there in the video description. Thanks for watching this video and stay tuned.